Hello, my name is Ash, and I will be discussing how our team achieved a Cinderella pipeline with a pick and place operation using a physical UR10 robotic arm and Genesis simulation. First, we set up the robot drivers on our local computer by specifying the driver package, the communication script, the robot type, UR10 in our case, and the robot's IP address. Once this is configured and executed, a graphical user interface opens, allowing us to visualize the real time position of the robotic arm. This confirms that a connection has been successfully established between the host computer and the robot. Next, we move to the robot's interface and run a script that enables remote control. This allows us to execute custom scripts and fully control the robot's behavior from our system. Once the connection is complete, we run our main program, which performs a pick and place task. This is achieved using the Genesis simulation environment, which is directly synchronized with the physical UR10 arm. Once we run the script, we start by activating the RealSense camera system, where a YOLO-based model detects the cube and outputs its XYZ coordinates relative to the camera frame, shown as a light blue text. We then convert these coordinates into the Genesis coordinate frame, shown as a light green text, using the equation below. This transformation equation, shown below, was derived by comparing multiple corresponding points between the YOLO outputs and the Genesis simulation. Note, we can neglect the z-axis conversion since the object remains in the same plane throughout the process. Using these matched points, we formed matrices and applied a coordinate transformation process to determine the relationship between the camera frame and the Genesis frame. This allowed us to generate an equation that matched the YOLO detected coordinates into the simulation coordinates accurately. Here, we have two screens, one displaying the simulated robot and the other showing the physical UR10 arm. We will demonstrate the pick and place algorithm step by step achieved by Cinderella, which shows how each movement is first performed in the simulation and then followed by the physical UR10 arm. Because the simulation is synchronized with the physical UR10 arm through ROS2 nodes, the joint states from the simulation are continuously sent to the physical arm. This allows the physical UR10 arm to replicate each individual step right after the simulation performs it, ensuring accurate and controlled motion throughout the entire process. Finally, the UR10 arm completes the pick and place operation, placing the object at the desired location specified by the user in the main script, demonstrating a successful Cinderella transfer. Thank you for your time and attention.